Hello, everyone. My name is Madeline Ballard, and I will be discussing with you the geology of Great Basin National Park, which is a national park that is located in White Pine County, Nevada. Here are the table of contents for this presentation today. The first topic I will be talking about is the geological history of Great Basin National Park, more specifically an explanation about the geology of the park and how it was formed. I will also mention information about the chronological timeline of the land formation in the park that currently exists. Next, I will be talking about how climate change has impacted the park along with how scientists have been learning about past climate change history of the park. Also, what climate change will look like in the near future for the park as well. For the third subtopic, I will be talking about region and geology, the connections that Great Basin National Park has with other parks in the US, along with rock formation in the park, climate history, and how human interaction with the land has impacted the park. Finally, I will be going over the erosion and deposition of the park. I will be talking about human interaction and how it has affected the park as a whole, the erosion and deposition of the land, and some of the trends in the ecosystem and evolution of the park as well. These are just a few of the topics I will be discussing with you today. There are other topics that I will be talking about as well, including historical establishment of the park along with the general evolution. All right, the first topic I will be talking about today is a geological history of Great Basin National Park. Within the geological history of Great Basin National Park, according to the National Park Service, the very beginning of the formation of the landforms on the park itself began in the Pleistocene, more specifically 10,000 to 1.2 million years ago. The Earth was experiencing a major glacial period known as the Pleistocene glaciation. However, when these glaciers melted into the bottom of the valleys, then the major lakes were formed due to the melted glaciers. Currently, these lakes are known as Baker Lake, Teresa Lake, and Johnson Lake. To add, there is evidence of glaciers occurring over 1.2 million years ago due to erosion from the melting ice by creating a U-shaped valleys in the park today. Regarding the rock formation of the rock in Great Basin National Park, majority of the park's rocks were formed during the Cambrian period. Most of the rocks in Great Basin National Park were formed in layers, metamorphism, and cooling of magma, which created the granite that is found in the park as well. Great Basin National Park has experienced several orogenies, including the Antler orogeny, which occurred during the Devonian era, the Sonoma orogeny, which occurred during the Permian era, and the Sevier orogeny, which occurred during the Cretaceous era. According to the National Park Service, during the Sevier orogeny, rocks in the Great Basin National Park had thrusted thick layers of rock on top of each other during the last orogeny, which was the Sevier orogeny. The main basin and range of the park were recently formed, which was about 30 million years ago. All right, the next topic I will be talking about today is the effects of climate change in Great Basin National Park. Now I will be discussing with you all the impact of climate change within Great Basin National Park. One example of a concern about the impact of climate change is air quality. There are certain pollutants such as nitrogen and sulfur deposition due to the rising ozone levels from climate change overall. Some scientists are concerned about the air quality for visitors and other people associated with Great Basin National Park. Another concern that came up while I was researching were the rock glaciers. Scientists claim that the increasing temperatures could result in changes to the shape and size of these alpine glacial features. Some of the future climate concerns include increasing temperatures, which result in increased precipitation. Not to mention, an earlier snowmelt rate by 2060 is the prediction by most scientists. However, this is all just speculation, but the scientists are concerned about the long-term effects of climate change, not only on our Earth as a whole, but more importantly, how they can affect the beauty and climates of our national parks here in the US. Right now, I will be talking about our next topic, the region and geology of Great Basin National Park. Okay, now I will be talking about the general region, starting with how human interaction has impacted the national park. From 12,000 to 9,000 years ago, the Paleo Indians inhabited the territory known as Great Basin National Park in the state of Nevada. During this time, they hunted mammoths and ground sloths that inhibited the area for food and for their skin as well. Centuries later, immigrants from the the East traveled across Nevada to settle in the state of California. However, those who did settle in Nevada used the land for ranching, grazing cattle in the South Snake territory of the park. Moving on to the geology of the park, we have high elevations within the park, including the Great Basin bristlecone pine trees, which have been on the land for over 4,000 years. Another interesting aspect of the park would be the Lay Layman Caves, which are limestone caverns within the territory of the park. Originally, the Layhan Caves were named after Absalom Layhan when he discovered them in the 1870s. The final topic I will be covering today is going to be the erosion and deposition and how it affects Great Basin National Park. The image above is Lehman Cave, which is a cave, one of the caverns that is located within the park. Right now, I'll be talking about the impacts of erosion and deposition on Great Basin National Park. One example of erosion that has affected Great Basin National Park is wind erosion. The region contains shrub plants, and with a combination of wind results in wildfires. These shrub plants are extremely susceptible to fire and can catch on fire very quickly. The damage that the wildfires cause is that they remove the cover from the plants and damage the soil underneath, which can ultimately cause the regrowth process to be more difficult. Not to mention, these wildfires can not only damage plants, but can also cause animals to run for shelter or leave their current environment. Another area of the park that is affected by erosion is a South Snake Range, which is essentially one of the main mountain ranges with a valley underneath. According to the National Park Service, erosion in this area is not uncommon. In fact, bulk of rocks exposed in this range are formed of sediments like sand, mud, and limey ooze. This area also has sediments and particles falling down from the mountain ranges and create alluvial fans, which are fan-shaped sediment structures that, when mixed with water, have a fan-like appearance at the bottom of the mountain. Also, the picture, figure 8, above shows what the South Snake Range looks like. Thank you for listening to my presentation. Here is the bibliography for my citation and sources for information. Now, here is my bibliography for my images throughout the presentation.